Maybe one more minute. I know it's pretty early for some people, and they just were able to grab a cup of coffee. Okay, so maybe let's start. My name is Rafał Małanij, and I'd like to welcome you on the webinar about MLOps in the context of the data science processes in the organizations. So a few words about myself. I've been into IT for over 15 years, doing various roles in organizations, starting with IT service management, doing a bit of project management, then focusing more on business development. My fields of interest was usually around data, but also cloud native, DevOps, big data, and genomics as well. You can know me as a person somewhere behind a few events happening in Poland, in Warsaw. So PyData Warsaw, Data Science Summit, and other conferences like that. As GetinData, we are a company that we help other companies, our customers, to use the data to unlock their potential in data they have, basically. So the GetinData was set up, was founded in 2014 by ex-Spotify engineers. And from day one, we had to focus on big data and then the cloud. The cloud at this point in time was a pretty new thing, but we knew it's going to be big someday. We have 70 plus big data engineers, so we're not a small company, but still with a startup feeling behind. And you can probably meet us on a few different community events in Warsaw, in this part of Europe, where we're pretty active, like Big Data Tech Warsaw conference. We're working with different customers, starting with startups through mid-sized companies to enterprise companies. And we're present in Poland and actually globally, because we have customers from US, from Asia, from Western Europe as well. So what we're doing, we're building white box end-to-end solutions, starting from the infrastructure, big data infrastructure for data ingestion, then ETLs, data engineering, then big data analytics on top of that, and machine learning and data science, so data analytics basically on top. We have pretty extensive knowledge and experience in stream and real-time processing. We focus on open source, but also we work with cloud managed solutions with major cloud providers. So when Carl Benz's wife, Berta, took their free-wheel car, the Carl Benz actually built, on the first ever long distance trip in 1888, she probably had not imagined that this would be a kind of a start of a new era in transportation and actually the catalyst of the new industry, the industry that we know right now as an automotive industry. Actually, Carl Benz made several identical copies of this patent Motorwagen, so free-wheel vehicle around this time. And historically, it is regarded as the world's first production automobile. Vehicles at the beginning obviously were required manual assembly in workshops or small factories. And it was like that until 1908, when famous Ford Model T appeared. Model T was produced through a moving assembly line. So standardized that all Model Ts were at the end produced only in black. Actually, at the beginning, there were a few colors to choose from, but they implemented an assembly line which required all the cars to be black due to a quicker drying time. In Henry Ford's autobiography, he wrote this famous quotation about the variety of choices he gave to his customers. So they could choose any color as long as it was black. Henry Ford is also credited for Fordism, a mass production of inexpensive goods, but also commitment to systematically lowering costs with technical and business innovations. Henry Ford introduced a few principles of assembly lines. So first of all, plan the sequence of operations. Plan the workspace the way it requires the least possible effort to complete the task. Deliver required components as close as possible at the right moment. And this is how the assembly lines are designed today, a sequential organization of workers, tools, and parts. The organization where the motion of workers is minimized to the extent possible, and all parts or assemblies are handled at the right moment, and each worker performs one simple operation. At the end, we have such production processes like in this video from Porsche plant, where actually every step is optimized to produce the car efficiently and with precision. This is a production line of Porsche Taycan, and you can find it on YouTube, obviously. The work of Henry Ford was picked by a few gentlemen running their manufacturing company on the other side of the Pacific Ocean. They applied their enhanced thought on the subject at Toyota in 1930s, known as Toyota Production System, called later as the Toyota Way. The exact reason why they work on that is not really known, but it is said it started with a requirement to solve the lack of standardization, and actually the problem they had with their first contract for the government. Over 50 years later, these methods were researched and called lean manufacturing, with defined 5 principles. So specify value by a specific product, identify the value stream for each product, make value flow without interruptions, let customer pull value from the producer, and pursue perfection. There's lots of focus on the value itself to deliver through the production process. Lean is founded on the concept of continuous and incremental improvements on product and process while eliminating redundant activities. If we add activity or functionality, we need to ensure the customer is willing to pay for it. This is the value he will pay for it additionally. Otherwise, it's waste and should be eliminated or integrated. And these principles began to be used in other fields. One of them is software engineering, software development, with the rise of DevOps movement that started in 2009 in Ghent, Belgium. Lean is one of the core values of DevOps, focusing on bringing value and eliminating waste by, for example, automation. Even though the software development process supported by DevOps sometimes brings surprising results, as you can see on this photo, it is pretty straightforward. We just put the business requirements into code, we automate our work, we test it and put it into operations. Generally speaking, we more or less know what we're doing. It is more a question of how we define what we want to do than finding out what we want to do. But in case of data science projects, it is different. The results are ephemeral. We know there might be something at the end, and once we nail it, we prove it works, we're gonna hit jackpot and make our business happy. And this is basically our goal, right? We make business happy and make their life easier. But it's not like we know from the very beginning what results we could expect. Obviously, we could copy paste some ideas from the market, but there is always some uncertainty. If we do something novel, the bid is higher and it goes up in parallel with the possibility of failure. Data science project is more like a research project than implementation. You start with an idea on what you could achieve with data. You formulate the research question, find data you could use, you define hypothesis, design methodology, and the way you could measure that. More like a plan for PhD thesis than software engineering. You have completely different starting point. Research question instead of business process, like in typical software. Once you want it to be a repetitive operation or run an experiment in a more structured manner, you might need a kind of platform to run there. When we mix learning with, when we mix machine learning with software engineering, we get much more complicated process, like on this diagram. We start with data collection and data ingestion. Once we have raw data in place, we want to inspect and select the right data that we push for annotation. Then we have to verify the quality of data, check if you would be able to use it in the rest of the pipeline. Once we show the data is correct, we prepare data sets for machine learning purposes, like splitting or versioning. Then we move to the actual training. Once we have model, we want to make sure it works as expected with the acceptable accuracy, and we have to deploy it and make it available for downstream systems. At the end, we have monitoring that helps us verify how the model behaves, if it works, and how it behaves, and react based on this behavior. If the model degrades over the time, we might want to train it or modify with new features or add new data set, new data source. There's another dimension of the process, the way data scientists experiment with new data sets. Typically, it starts with some one-time data exploration of a new data set to see what's there, check how it can improve existing model or help to create new one, this kind of experimentation. Once this source is validated and proved it might work and bring some value to the organization, there's a batch process initiated, so it can be used widely and prove bringing value in a kind of a repetitive manner. If this is successful, why not to modify it? Why not to modify the model to work in real time on a stream of events? And this now actually sounds pretty simple. You have an experiment, you make it a repetitive experiment, and you make it real-time experiment, maybe not experiment anymore, but real-time. But it can be demanding from the process perspective and from technology perspective as well. Might require multiple implementations. As we talk with organizations that has already made their first steps in advanced analytics and machine learning, we see the same problems. Data science projects are a combination of these two fields, software engineering and data science. Experts coming from these domains, they speak different languages. They do not understand each other, what creates inefficiencies. Long development time, so working with data takes time. The process has more steps. It is more complicated. Going through the whole data science cycle can last for months. Even when the solution is ready, there's sometimes long time before the users can actually use it. Lack of best practices. So it happens that different teams solve the same problem differently without standardization, creating redundancy actually. Waste and duplication. Many use cases are reinventing the wheel, what loads of inefficiencies and waste basically. Resource constraints as well. So even though you might have big plans about machine learning in your organization, you will probably fail on finding enough experienced data scientists to implement machine learning at scale. You have to scale up your capabilities internally with the resources you have. Lack of engineering knowledge, that basically means that data scientists has to be supported by software engineers. In one of their organizations, they realized that for every data scientist, they need 3 engineers on average, and they just could not find enough of them. Not discussing the cost of having so many software engineers. And the literacy, low data literacy within the organization. Even if the data science team is doing a really good job providing solutions, business users across the organization might not be able to understand how to utilize that solution, as this is really new technologies. So when you compare it with the beginning of the automotive industry, we are probably somewhere at the end of manual assembly era, with many organizations aware that they need a more scalable approach, kind of an assembly line. So here comes the MLOps, which is sometimes defined as a DevOps for machine learning. However, it's much more than that. MLOps is a set of best practices for businesses to run data science and machine learning successfully. It is kind of a model factory, a production line for models, making them available as data products in the organization. It is like a modern assembly line designed as a sequential set of operations performed by data scientists and automated by technology. An assembly line where the non-analytical additional tasks, kind of inefficiencies and waste, are minimized to the extent possible. And all the components are available at the right moment pretty easily, so data scientists can focus on one task, preparing the model, working with data, basically. MLOps and the MLOps platform that supports MLOps is the bond between the world of software engineering and the realities of data and data science. We have here support for the software development lifecycle, versioning, automation in the form of continuous integration, continuous deployment, or machine learning pipelines. We have unified access to data and the tools to work with it. The platform makes sure that no data scientist has to think about the security standards in the organization, what are the data governance processes, and whether this data is consistent or can be used. Finally, the platform makes sure that the user does not have to think about where and how the model is to be trained, where to run it, and how to monitor the operation of this model, both in terms of technical and business metrics. Metrics like effectiveness of prediction, for example. We can talk about MLOps as machine learning on an enterprise scale, meeting the enterprise requirements. When we look at the logical architecture of MLOps platform, we can see 3 major areas: experimentation, training, and serving, with monitoring included. Sometimes monitoring is a separate component, right? But regarded as a part of the serving. First, data scientists experiment and design a model in a so-called data science workbench, experimentation space, kind of a reliable laboratory that allows for free and isolated experimenting. The result of the code of the work is actually the code of the machine learning pipeline, which is managed in the code repository. The code goes through the continuous integration, continuous deployment, and compiles. This CI/CD compiles the code into the training image. We run the image on the training platform and achieve a ready model stored in the model repository. We gather visual statistics and all metadata about the model and the version of the model. Finally, we come to the deployment for production. So another continuous integration and continuous deployment is forcing the review of results and engineering standards and implements the model on the infrastructure serving the model. then actually can be run in production. So at this point, we started with the detailed monitoring, which actually allows us not only to audit or provide us technical monitoring of the model responses, so we know if it's working or not, but also how the model affects business and production applications. So this is a basis for A/B tests of model variants. The optional part of the solution, but the ones that solves many problems, is a feature store. It is a centralized repository of features that are input of each training procedure of the machine learning model, and then the model itself. The features standardize and catalogs the time calculated features. So we have a time dimension over there, and that can be shared between machine learning projects. Features can also contain predictions, so as to support the scenario where the output of one model is actually an input of another model. And one of the most important things is that is the fact that the same identical features from the repository can be used in the experimentation phase, model training, and most importantly, model serving. By ensuring that the model response does not differ in production from training due to differences in feature conversion. So we are sure that our model is running on the same data, on the same features through the whole life cycle. MLOps in general looks the same, but will probably be slightly different in every organization. The clue is to understand it, understand how your organization works with data, standardize the way you work with data, and develop best practices, and then scale it throughout the organization. Common and unified architecture helps a lot. First of all, provides helps to save some money, so less maintenance costs and less maintenance effort, basically, which is sometimes much more important than just pure money. Provide more convenient way to develop or test models for data scientists, so they do not have to be the jack of all trades. So focus on what they're good at, so analyze data. Makes it easier to run and build individual models with more modern architecture. Make it available, developing common assets to be reused and shared, and provide some secure access to data and development environments. So you are sure that your data and actually your models and the way people are working is secure. You don't have like passwords flying all over the emails or something like that. Good practice also makes work with the platform more predictable and more transparent. Last but not least is the point that modern big data systems is designed with many integrated but interchangeable parts. So if needed, you can switch part of the solution with other software that will work better for your needs, provide functionalities you want to use. This area is under rapid development, so you have to be prepared for constant changes. Just to sum up, what is MLOps and why it is important and how to implement it actually. To scale machine learning in an organization with success, it must be treated like the field of software engineering. The MLOps approach gives the desired efficiency and consistency of the operation of models, the speed of creation, iteration, and minimize the time needed to implement the finished product. In engineering, the product of work is basically not software, but the code that creates the software. In the case of machine learning, it is the pipeline code. The pipeline code which you can test, repeat, track changes, and actually monitor. And last but not least, there are actually many parts of MLOps, but as long as they are well designed and implemented, they're independent. So experimentation space, training part, serving and monitoring, and repository of training data, all can be implemented gradually. MLOps is more like a journey, change the way data science and machine learning is perceived and used by the organization, changing it into the machine learning and AI-driven organization. So all MLOps implementation projects are super exciting, as they do not only involve technology. The technology which is really cutting edge, pretty new, in some cases has just arrived, like for example, Google Managed Feature Store, which is in preview and was announced like a month ago, or Vertex AI platform, which is a managed MLOps platform. But it's also very connected with how the organization works with machine learning right now, how they want to work in the future, and how they want to make the organization machine learning and AI driven. And this is just the beginning of machine learning. Observing the speed of development, I cannot imagine how the whole landscape will look in 2 years' time. For sure, machine learning modeling will be automated. The open question is when you're going to start doing it, and start doing it in a structured and more process-like way. Thank you so much. If you have any questions, I think you can put it on the QA. We have still a few minutes to answer questions you might have. So there are no questions. If you plan or have if you plan to start this kind of initiative in your organization, or you want to discuss, share some experience, just let us know. We are working on a couple of machine learning operations projects for large organizations, for small ones. Every project is different, but the whole idea is generally the same. Thank you so much for attending, and have a great day.